We get an alert. Our user service is taking too long to respond. Clearly something is going wrong. Tickets start coming in, saying the platform isn't accessible, but we still see about 80% of our requests coming through. We start investigating, but there are too many logs and we can't find a cause. 30 minutes later, problem solves itself. We still have no indication of the root cause, so we create an internal ticket to investigate further. Nothing for 2 weeks, don't hear a beep. Still can't really find any details about what went wrong, and our best guess is hopefully it was a network blip. Now the problem back, and it's recurring. Over 50% of our requests are failing. We figured after poking a few things, we might as well try restarting the gateway. It immediately comes back, everything's fine. Just like that, the issue is resolved. Now we have an idea that our user service might be a symptom and not the cause. But what's going wrong with our API gateway? This issue persists sporadically for months, and we can't keep allowing this to happen. So before we dive in more about this problem, how we fixed the wrong one, and how Datadog helped us find the right one, I wanted to give some introductions. My name is Trevor Bramwell. I'm a senior systems engineer at the Linux Foundation, and I work on the back-end team of our project control center, and I also maintain our current API gateway. And this is my co-presenter, Alan.
I'm Alan Sherman. I am a senior cloud operations engineer at the Linux Foundation. My team is responsible for deploying, maintaining, and troubleshooting all of the code maintained by Trevor and his team.
If you're not familiar with the Linux Foundation, we started in 2000 to support the growth and adoption of Linux and open source software. Since then, we've grown in the past 25 years to support over 900 open source projects, to which we provide everything from infrastructure, event management, training, legal support. And we've grown beyond just open source software to support open data, open hardware, and open standards.
So in addition to all of the big flashy stuff, the Linux kernel, the Cloud Native Compute Foundation, we also work on an internal platform that we call our LFX platform. This platform is used to help provide insight into how healthy an open source project is, help open source projects control their infrastructure. It scans for security vulnerabilities, handles open source license compliance, mentorship, crowdfunding, etc. Some of the people in this room might have interacted with our individual dashboard. That's where individual contributors can log in. They can see their own open source contributions. They can see any training or certifications they've taken, any events they're going to be attending. And we provide all of this to our members as a benefit to being part of the Linux Foundation. It is written and maintained by our in-house development and operations teams. So a quick, brief overview of the architecture of the LFX platform. Our platform is deployed on AWS. Our front end consists of a cloud front deploying a single page application out of an S3 bucket. And that is then backed by a backend for front end deployed in ECS, where it's doing some server-side rendering and caching. After our front end, it talks to the API gateway, which is kind of the heart of our infrastructure that all of our traffic passes through. And then we have microservices behind that, a combination of ECS services as well as Lambda microservices. And those services talk to a variety of different backends: Postgres, DynamoDB, OpenSearch, Valkey, etc. So Trevor's already walked through the initial issue that happened, but what did we do in response to that? So initially, we got that user service long duration. That's a Lambda alert that the Lambda was taking more than 60 seconds to complete. We also then just looked at what users were reporting, and our users were reporting almost exclusively 500 errors when trying to access our user service. And because of this, our entire platform was completely unusable. So what do you do when you get a bunch of user reports about 500 from your user service? You fire up curl and see if they're right. Quickly found out we could see the same exact problem as them, and so we logged into the AWS Lambda dashboard. And when we logged into that dashboard, here's a few of the graphs we were greeted with. On the first graph here, you can see that our error and success rate completely inverted. We went from a healthy service to a completely failing service. We also had a long duration. That was the alert we initially received. Not only did the duration time spike, but more importantly, it plateaued. Now, in this graph, it's plateauing at 90 milliseconds. This was taken, or 90 seconds. This was taken a little bit into the troubleshooting. Initially, that was a 60-second plateau, and that'll be important in a minute. The other graph we saw that was interesting was the total number of executions. And at first, we just initially assumed that this was a stampeding herd. A bunch of our users are hitting F5 and hitting the pages over and over again. Our own code is retrying, and so we have a huge spike in traffic. It turns out this was actually a bit of a red herring. On top of all of that, we couldn't reproduce this at all. We couldn't reproduce it in production or any of our other environments. It meant that for several weeks, we were essentially waiting for this to happen, doing as much troubleshooting as we could in a few minutes before we restarted the gateway to mitigate the production issue that our customers were experiencing. And when it wasn't one of these issues, everything was just fine. Response times were a few hundred milliseconds, no symptoms whatsoever. So this whole time we were focused on the user service. That was the initial errors that were being reported. Because of that, we missed errors that were coming from our other microservices. And a big part of the reason we missed that is because we didn't factor in how our application worked in the first place. One of the things we later realized is that the user service was being called on every single other API call. In order to authenticate whether or not that user could make the API call in question, we were constantly hitting our user service. In addition to that, it was just our most frequently used service in the first place by total volume. And not only was it the most used, but it was frequently used at the start of every page load. In order to finish the page load, we needed to know what projects and organizations a user was part of. And this meant that user service calls were disproportionately front-loaded in our application compared to calls to our other services. We didn't have a single pane of glass that could aggregate all of this data in one source. At the time, we were using FullStory for our real user monitoring. We were relying on AWS's built-in monitoring for infrastructure level monitoring, and we were using Datadog to aggregate alerts and log information. Because of this, we couldn't see information across multiple services. We would just go to the AWS page and see the stats for one service, but that didn't tell the whole story. And we didn't have any end-to-end tracing. We only saw aggregate data. And because of this, we ended up making some initial assumptions. Between the 500 errors coming on our front end and those initial graphs I just showed you, we assumed the user service was the problem. And that's going to be a reoccurring trend throughout this. We made a small number of very important assumptions that ended up costing us a bunch of time and effort. So to explain how important that end-to-end tracing that we didn't have was, we ran into what I'm calling a 60-second timeout trap. So we ended up adding in some more debug logging and tracing into our user service specifically. And after doing that, we realized that only a small portion of our requests going to the user service were actually showing up in our logs. So we had to zoom out and figure out where else those requests were ending up. And we ended up looking at our API gateway. So here, we have an application load balancer sitting in front of a ECS container running Express.js as our gateway, and then that's talking to the various microservices in our backend. And here we can see that regardless of what service you were reaching out to, you always end up making an authentication call to the user service to verify that that user has access to that endpoint. Now, we already established that there's a 60-second timeout happening at the Lambda, and that was happening. But there was another 60-second timeout on the ALB. And these two timeouts masked each other. So going back to our initial curl debugging, we're sitting at our workstations, running curl, getting these 500 errors back after 60 seconds. We then go to the AWS dashboard. We see a 60-second timeout on the user service Lambda. Everything lines up. It makes perfect sense. Something is hanging within our user service. Maybe it's a bad for loop. Maybe it's a bad database connection, but the user service is the problem. When in fact, only a small percentage of the traffic was actually making it through the API gateway in the first place. So a bit of a spoiler, it was the API gateway. But there was so much of a stampeding herd on the API gateway that when we were looking at the Lambda, we still saw an uptick in the total number of invocations on that Lambda. Now, we did have other timeouts. We had application level timeouts. When the service was invoked, we created a context in Golang that was passed from call to call. And then those individual calls also had their own timeouts. But these timeouts were consistently set at 60 seconds. And we now had 2 different 60-second timeouts happening before we ever invoked the function in the first place, which meant instead of getting really good logs and errors out of our application, all we got were exit 1, killed by Lambda, Lambda timed out errors. It was a very useful source of information that we had completely cut ourselves off from by not properly timing our timeouts. So how did the API gateway have a massive stampeding herd issue that we missed? Tech debt. The API gateway was our single biggest piece of tech debt in our infrastructure. The API gateway was running an application called Express.js, which, as you might be able to guess, is a Node.js app. But at the time that this incident started to happen, that program had already been deprecated. It had been deprecated for a year or 2. Because it was old and deprecated, it was being deployed on Node.js 8. We actually ran into an issue about a year prior to all of this, where the Node.js 8 container had old enough root certificates that it was no longer recognizing some of Let's Encrypt's newer intermediate certificates as being valid. That caused a minor production issue, and when that happened, we upgraded Express.js to run on Node.js 12. But at the same time, we tried to get it running on newer versions. We tried to get it to run on Node.js 14, and we learned that without a major refactor, that wasn't going to happen. But at this point, Node.js 14 was already end of life. We were several years behind the curve. To its credit, it did keep working, at least until it didn't, so we kept kicking the can down the road. We had an end-of-year goal to replace our API gateway, but we had had that same goal for several years. Tech debt 101. It had gotten bad enough that internally we started to use phrases like black box to refer to our API gateway. We did have logging enabled, and those logs were going to Datadog, but there was such a bad signal to noise ratio that we ended up having to create a new Datadog log index, literally called bad actors, that had separate retention periods to deal with the influx of logs. And even that didn't solve our logging problem, so we eventually had to change our log forwarding to only forward a percentage of our logs to Datadog in the first place. On top of this, we didn't have any application level monitoring of our gateway. We had the built-in monitoring of ECS on the container itself, and we also had monitoring of the infrastructure components like the load balancer in front of it, but nothing that could give us details about individual calls, individual endpoints, individual paths. That was all a black box. And what that meant is that when we were doing this assessment, when we realized only a small portion of our requests were making it to the user service in the first place, it was an easy out. We once again made an assumption. Of course, Express.js is failing. It's old, it's end of life. We've been needing to replace it for a long time. So it became the easy target, the thing that we had to replace.
So we started replacing the gateway. Clear the next step. Started researching and testing other solutions, started in April of 2023. Ended up choosing Traffic as the best open source option for a variety of reasons. We wanted to support things going forward as well, but it took a lot of work. One of the first things we need to do is we're replacing this component that everything goes through. We need to make sure it matches exactly what is going on currently. So we have to make sure all the routing is one-to-one. We need to migrate all of those routes. We had to write a custom plugin for Traffic because it doesn't natively support AWS Lambda, and so many of our services were running on that. And we also had to implement authentication plugins and ensure headers were being forwarded. And overall, it took 6 months of work, which is great. We did it, patted ourselves on the back. We were super happy. And this...
So one of the big takeaways from this whole process was just how little we had documented about this. It turns out that there were several subcomponents and an entire database that I wouldn't have drawn if I was asked to initially map out what our infrastructure looked like. Now, we did have the information in-house. If we had gotten a few people together in a room, we could have accurately mapped out how this all worked. But that's just not realistic. You can't count on any one person knowing everything. We needed documentation that walked us through both how these components interacted with each other and how they all worked independently. However, after replacing our entire API gateway, we finally had a good understanding of how it actually worked. We went through and we created that documentation, and in early December, we were able to do our production cutover to the new gateway, and to the full credit of the LFX team, it just worked. No issues whatsoever, no downtime. All of the endpoints were a one-to-one match with our existing API gateway. And we were able to go into that holiday break with a nice, peaceful, no major issues whatsoever.
Woohoo! 2 weeks into January, did nothing. 6 months of work, not down the drain, but essentially, all of our symptoms returned. All the alerts continued just as they were before. We realized Express Gateway could not have been the root cause. And when we built out the gateway, we had tracing first in mind, so we had a lot more visibility into what was going on. So we started digging further into the components and the pieces, and specifically our access control system. ACS, or our access control system, was largely an unknown service. It wasn't well documented in our infrastructure. It was deployed as a sidecar to the gateway. And it was used on every single request that went through before it even got to the user service. And it uses an internal, what's called Open Policy Agent database. So a little bit more about like the architecture of how it works. It starts by fetching this S3 bundle, and it caches it to the local disk. When an authorization request comes in, it comes in with a user and a path. The user then is queried from the user service to verify they exist, and then we check their permissions against the bundle that's cached locally. Now that we have tracing in there, and we had a local development version of it, I started running Siege on it. And I sent as many requests as I could. And I started noticing, wait, every time more and more requests come in, it gets longer and longer and longer to respond. Ha ha ha, this is the real problem. And we were finally able to reproduce it. So we found the right problem. Yay! And though it took many months of debugging and red herrings, we started finally implementing solutions, which were actually very simple and straightforward, and didn't take that long. We started caching our user service requests, reducing our load to the back end. We started caching our ACS itself, so those queries didn't have to go out to the user service. And then we scaled up our gateway deployment. There wasn't anything previously that we saw where we needed to scale up, but having the extra couple of containers there to handle requests was really quite helpful.
All right, so don't repeat our mistakes. What are some of the key takeaways that we got through this whole process? First is documentation. Document everything as thoroughly as possible and keep that documentation up to date. Some of the changes we made internally is we started implementing a documentation first development practice. We write our docs first, we circulate that internally, we get feedback and review on it, and then we implement the new feature. This ensures that we have documentation in place once that feature is deployed in production. We also created an architecture team. This team is responsible for reviewing any major changes to our services. And there is a change review process that you need to go through when making major changes. And then every few weeks, the architecture team gets together with all of the team leads and managers, and we review these changes. And the very change review process itself produces an initial piece of documentation before we've even decided what the solution to the problem should be. And then another more specific tool that we started using heavily is a diagramming tool called Mermaid. It's a markdown native diagramming tool. This lets you store your diagrams in your code repository, version manage them with Git the way you would your code, and then they get natively rendered by GitHub, and you can have nice diagrams built into your READMEs in all of your code bases.
The other thing we learned is that you need to trace everything. APM is great and having that tracing there, but one of the most powerful things we saw was distributed tracing. Being able to see those requests as they come in, hit the ALB, hit the gateway, and go out to our services, and see where the timeouts were happening was very, very helpful. Another additional thing that helped was adding connecting our logs to the trace spans so that we could have a clear indication of where in the code certain things were happening. And then we traced, again, everything. We included databases, Redis caches, basically anything Datadog supports, you should add tracing to it right now. And if it doesn't, there are ways on the docs of how to do that manually.
And then finally, throughout this whole process, we repeatedly made bad assumptions. We highly recommend aggregating all of your data in one place and leveraging that data to make data-driven decisions instead of assumptions. Now, you're all professional engineers, you're smart people, your experience and your knowledge of your own infrastructure is incredibly valuable. So by all means, trust your gut and make educated guesses, but then back those guesses up with data. You need to be able to prove to yourself and prove to the rest of your team that you found the right issue. If you don't, you can end up spending months only to solve the wrong problem.
With that, thank you. And thank you for listening to our story, and thank you for Datadog for giving us the opportunity to share it with you today. I think we have about 10, 15 minutes for questions. If you'd like to get in touch with us after, here's our contact details.
There's also a mic on both of the aisles in between where everyone's sitting if you want to ask questions.
So it sounds like you got into a deprecation process. That sounds like it's a culture issue that may have happened. One, how did you shift that, or did you shift that successfully? And how are you avoiding getting that in the future, of running into that same situation of the staying up to date and not being prioritized?
Yeah, so I think this issue was a big part of forcing that cultural shift. When we had these downtimes, it would result in customer complaints. Some of our services are fairly time sensitive, like scheduling Zoom meetings that executives are trying to join. So it became unavoidable that we had to do something about this current issue. And I think our leadership team recognized that we had to change our priorities. We couldn't just push for new feature after new feature. We needed to deal with some of this tech debt that we knew was there. As for how we avoid doing that in the future, the architecture team is a big part of that. They have pretty rigorous standards for new features and new applications to ensure that we're not reverting to bad practices we had in previous applications. And then, as an organization, we just have to stay vigilant on, what our priorities need to be in balancing the new features with maintaining our app environment. I can't guarantee that we're not going to have a problem like this in the future, but I think we, as an organization, learned a lot through this process.
Thank you. Hey, fantastic presentation.
Thank you.
Quick question on some of the cultural stuff that you guys were talking about. So I hear that you guys are doing documentation first, then going through review, and then implementation. So have you guys experienced any issues culturally with keeping documentation up to date and also very long and repetitive review cycles? Have you guys encountered these issues?
Not so much the review cycles. Keeping documentation up to date is always a challenge. I know we have what we want to do. It's not so much that our documentation that we started with is always up to date, but we start from that mindset of, before we even attack the problem or start a new service or something, we have to have documentation in place to know where we're even going. And then we spend a lot of time going back, and every time someone's working on a change, take a look at the README. Is there something missing? Okay, make sure it's on our code review. Like, hey, update the README while you're doing this. Make sure the documentation is up to date with the service while you're going through. Has really helped.
Cool, thank you.
In the presentation at the beginning, you showed a few graphs from the Lambda service, I believe, for the user service, and you showed that the error rate, success rate graph basically was completely inverted. And so that was, if I understand correctly, initially suspected to be the root cause, but you later identified the sidecar container and the gateway. So what was the actual end cause of that inversion in the user service? Was that also calling the ACS service?
So, only a small percentage of the traffic was making it through to the user service in the first place. And then there are multiple scenarios where our user service was then going back through the API gateway to call one of our other microservices. And so there was a handful of successful requests making it through. It wasn't a 100% failure rate, but it had to essentially get 3 successful calls in a row. It had to pass the authentication service, then it had to get forwarded along to the user service itself, and then it had to wrap back around through the API gateway in order to hit the project service or the organization service in order to actually return a result to the end user that was successful.
Got it. Okay, thank you.
Hi there. Again, great presentation, thank you. Looping back to the culture question, any tips on just helping moving the cultural needle, if you will? It sounded like, or was it the case that your leadership was like, yep, no need to sell us, and we agree, and did they drive that? Or were there some kind of slick, psychological tricks that you employed to get people to make that cultural shift?
I don't want to say we've solved the culture problem either. It's always a challenge because we're one of many teams at our organization. Definitely leadership. I think I recall because we're under product, and we said, okay, maybe we're going to not deliver 100%. We're going to do 80% and use that extra time to focus on driving down this backlog of tech debt. The other thing is we have a monthly IT, all the teams get together. And I think that's been helpful to have a time, at least, a point in time where we can all talk about the cultural things and relay those to everyone else.
And then follow-up question, if you had to pick one of those strategies as the most effective with regard to shifting the culture, what would be the top 1 or top 2?
Probably getting together on some sort of cadence all together and focused on trying to talk about, okay, let's take a big picture approach of what we're doing. Let's talk about the things that are going good and bad in our teams and how we can, move forward and have everyone give ideas of, things they think can improve and hey, let's talk about this team. Talking about how are you doing things over here? How are you guys doing things over here? Let's share our knowledge and benefit from that.
Yeah, and something else I'd add to that is that architectural group serves just as much to do retrospectives as it does proactive approvals. So when we do have issues, we're communicating, we're figuring out what went wrong, and we're identifying, which of our standards could have prevented this, and making sure that we're increasing that coverage of our own internal standards.
Perfect, thank you.
Yeah. Any more
Awesome.
questions?
Thank you all.
Thank you. Appreciate your time.